Hi everyone, welcome back. So once again, we're getting to those limits of size applications. So what do we have here? Well, we have a hole and a shaft. It will result in a 0.0016 maximum and 0.0006 minimum interference with the rest button. So rest button right here, the hole right here. As you saw, it didn't say there's ever a point where it has clearance. No, it's interference the entire time. So this is going to be a force fit. Okay. So 0.0016 maximum and 0.0006 minimum. And here is our rest button. So first off, let's find the limits of size for the rest button. So we have 2510 plus 0.0004. So that would be equal to 0.2514. And it can't be smaller than that, so its limits of size would be 0.2514 and 0.2510. Okay, so when we have the maximum interference, we're going to have the biggest shaft, and so our hole will need to make sure that we have that maximum interference. Okay, so that would be the smallest hole. Smallest hole, biggest shaft when we have this interference. So 0.2514. And what I really want here is I want to make sure that my hole is 0.0016 smaller than this. So minus 0.0016. And what do I get? Well, if I do my math correctly, which is never a given, I will get, yes, 0.2498. So that would be the smallest hole I could have. Any smaller than that, I would have a larger interference if we had that worst case scenario. Now let's figure out the minimum interference. Well, the minimum interference would happen when I have the smallest shaft and the largest hole. So this will be the maximum size for my hole. So 0.2510. I'm going to subtract off that minimum interference, minus 0.0006. And then let's do some math, and that comes out to be 0.2504. Okay, so with that in mind, my tolerances on my hole would be 0.004 up and minus 0.0002 down. Okay, that looks pretty good. Now let's go ahead and draw this. We've done our math, and we figured it out so far. Remember, for both these cases, I had to figure out what was the worst case scenario for the maximum and minimum. For the maximum, it was the biggest shaft and smallest hole. For the minimum interference, smallest shaft. Smallest shaft and the largest hole. Now let's go ahead and draw this. So I have my part. Okay. Now you see that that hole is shown with dotted lines. That's a hidden line, which is saying that I can't see this feature, so I'm not going to put any crosshatches. It means I'm looking at it from the outside, and it's kind of like I have X-ray vision. Let's add a center line in here. And now let's add in some extension lines off to the side. Now these are fairly close together, so to make this look as nice as possible, I'm going to do things a bit differently. I'm going to put the number inside of these two extension lines. I'm just going to put my dimension line there, which shows, where this dimension I'm about to add is going to go from. I'm going to extend it upward, straight line, and then perpendicular to that, off to the side. I'll use my diameter symbol because I'm setting the diameter of this hole. And then there are actually two ways I can specify this. I can give it as limit dimensions, which would be 0.2504 and then 0.2498. That's one way. Or I could have specified it using my plus or minus tolerance, my bilateral tolerance. So give the base hole size, which is 0.2500, and then plus 0.0004 and minus 0.0002. So that would have been the other way I could have done this. Two ways, both equally correct. So thanks for listening. I hope this helps you. If you're ever struggling with these kind of like interference ideas, act it out. I mean, if you have like a paper towel holder and a couple pencils and like a highlighter, you can see which one would have less room to move around. So the bigger that item is that you're trying to fit into the paper towel holder, the harder it is going to be for it to move around. So hopefully that helps you. Thank you very much for listening, and I'll see you all next time. Bye-bye.